Hi, and welcome back. In this video segment, we're going to be talking about solving inequalities. Solving inequalities is nearly the same as solving regular equations. There's one simple difference, and we'll talk about that when we get to multiplication and division. However, for addition and subtraction, the process is exactly the same. Nothing changes and we don't do anything with the inequality sign. So in general terms, if we know that A is greater than B and we add some number to A and add some number to C, the same number, A is greater than B, then A plus C has to be greater than B plus C. Additionally, if A happens to be less than B, and this time we're subtracting the same number from both sides, the statement holds true that if A is less than B, then A minus C has to be less than B minus C. Let's look at an illustration with just some simple numbers. If A is greater than 2, and what I told you was if we add the same number to both sides of that inequality, the inequality sign won't change, but let's just check it out. So 6 plus 4 is 10, 2 plus 4 is 6, and what we need to ask ourselves is 10 greater than 6? And indeed it is. Here, if we subtract, I said 12 is less than 20. That's true. So if I subtract the same number from both sides of that inequality, my inequality sign should remain the same. 12 minus 10 is 2. 20 minus 10 is 10, so 2 should still be less than 10. The difference comes into play when we're working with multiplication and division. However, each side of an equality can be multiplied by the same positive number without changing that solution set, meaning the inequality sign stays the same. However, when we multiply or divide by a negative number, the inequality sign is flipped. It goes from greater than to less than, or less than to greater than. Let's take a look at some numerical examples. So if I multiply by a positive number, 6 times 2, 2 times 2, we're seeing if it holds true if I multiply both sides by a positive that that inequality sign stays the same. 6 times 2 is 12. 2 times 2 is 4. So I'm wondering if that stays the same, and it does. Now, I have 6 is greater than 2, and according to the example above, I need to flip that sign if I multiply by times negative 2 and 2 times negative 2. So I went from greater than to less than. So let's look at the numbers and see if that holds true. 6 times negative 2 is negative 12, and 2 times negative 2 is negative 4. So instead of keeping the greater than sign, we do need to change that to a less than sign because negative 12 is less than negative 4. Let's look at an example. Solve for y and graph the solution set. Y minus 3 equals negative 12. So I still need to eliminate and have my variable isolated on one side. So I'm going to add 3 to both sides. So my y stands alone. Negative 3 plus 3 drops out. I leave my inequality the same. and negative 12 plus 3 is negative 9. Now, to graph this, when we have just one variable, we're going to use a simple number line. I'm going to put 0 in, negative 5, negative 10, and negative 9 is right here. And since I don't have an equal to, and I've just got the greater than, I use an open circle because it does not include negative 9, but every integer that is greater than or to the right of negative 9. So I use an open circle when I have just a greater than or less than sign, but not the equal to sign. And everything goes right from there. Okay, solve for x and graph the solution set of 3x minus 5 is greater than or equal to 2x plus 7. We still need to isolate our variables, get them all on one side and all of our numbers on the other side. So in this case, I can either subtract 3x from both sides or subtract 2x from both sides. And since I happen to like my variables on the left, I'm going to subtract 2x from both sides. So 3x minus 2x is x. And I'm going to just write that greater than or equal sign down. 2x minus 2x simply drop out. And the right side of the equation becomes 7. Now I'm going to add 5 to both sides. My goal is still to get x on one side and all the numbers on the other side. And I leave my inequality sign the same. And 7 plus 5 is 12. Now to graph this, I put out my number line again. And I'm going to put 0 down here because I've got a lot. 5, 10, 11, 12, and then it'll be 15, etc. Since in this case I have greater than or equal to, I'm going to use at 12 a closed circle, meaning that 12 is included in the solution set. Greater than tells me I'm going to go off to the right, to the numbers larger than 12. So all the numbers greater than 12 and including 12 are included in the solution set. Please pause the video at this time and complete example 6, remembering if you divide by a negative that you need to switch the inequality sign. Flip it around. Start the video when you're finished and check your solution. Let's see how you did. We have 4x minus 12 is less than or equal to 6x plus 20. We can either subtract 4x from both sides or subtract 6x from both sides. It really doesn't matter which way you do it, but because I like my variables on the left, we're going to do it this way. So I have 4x minus 6x. So I have negative 2x minus 12 is less than or equal to 6x and negative 6x. Drop out, and I'm left with 20 on the right side of that inequality. Now I'm going to add 12 to both sides to get my x term standing alone. I'm left with negative 2x on the left side, less than or equal to 32. At this point, you should notice that you need to divide by negative 2 on each side, which tells me I need to go from less than or equal to greater than or equal to. The negative 2's cancel, and I'm left with x is greater than or equal to negative 16. In graphing that, I'm going to put my number line out. And am I going to use an open circle or a closed circle at negative 16? I'm going to use a closed circle because I have the equal sign. So I put a closed circle above negative 16, and greater than tells me to go to the right. Any number greater than or equal to negative 16 will keep this inequality true. Please stop the video and continue on to the self-check for solving equations and inequalities. Make sure you print off your report and bring that into school with you for our next session. Thanks. And don't forget, if you have questions, you might want to jot them down now so that we can go over them in class and do some more examples. Have a great night.